Hello and welcome. We're going to talk about classes and object-oriented programming. First, we'll talk about the class keyword. The class keyword allows you to create classes. We'll create a class called mkLevel. It opens up like an object, but it does have something called a constructor inside of it, and that will resemble a function or a method. Now, your constructor can take in variables. I'm going to take in one variable called level name. And level name is going to be assigned within the constructor. It's going to be assigned to this.level name. It'll be equal to level name. And we will talk thoroughly about the this keyword, but first I want to make one instantiation of the mkLevel class. So we will have a const, let's call it space. It will equal a new mkLevel, and we'll pass in space for its name. Now we can console.log space and run that. Now we have an instantiation of the mkLevel class with a level name of space. So what is happening with the this keyword? The this keyword is going to refer to the const. Whatever you named this new mkLevel, space is what this refers to. So space.levelName would be equal to space, and this.levelName would also be equal to space. So we're using this within the class here in order to refer to what will be made in the future, this new mkLevel called space. And there might be hundreds of mkLevels or thousands of them. And we're going to need a word to refer to all the mkLevels. So we use the word this. Let's take a look at a diagram real quick. So we have a class mkLevel. Here's your constructor with the level name. This.levelName equals level name. That's what we just wrote. But here's a different const, a const called rooftop. That's a new mkLevel as well with the name of rooftop. Now this.levelName is rooftop.levelName. That's what the this keyword is doing. It's giving us a variable to refer to the consts that we make that are new mkLevels. Next, we'll talk about methods, and methods are going to look exactly like functions. So we're going to have a method called createEnemy, and this is going to create us an enemy for each level because we have a level name space, but we have no one to fight in our Mortal Kombat level. Let's get ourselves a random enemy. Here are our options for enemies. It'll be an array of 3 of my favorite characters from the game, Scorpion. Let's have Sub-Zero, and let's also have, how about Johnny Cage? And now we're going to assign this.enemy, there we go, will be equal to, and how I'm going to do this is options, and inside here we could pass in a number corresponding to either Scorpion, Sub-Zero, or Johnny Cage being 0, 1, or 2 because we're 0 indexed within our array. So in order to do that, I'm going to have math.random start us out. That gives us a number between 0 and 1 excluding 1. So in order to get that between 0 and 2 excluding 2, what we'll do is multiply it by 3 and then round it to the floor. So math.floor would round us down. And now we'll always have a number between 0 and 2, and it will be all whole numbers or integers. So if we want to use this method that we have, we can use dot notation to access it. Space dot createEnemy and invoke it, and then we'll run this. And now we have an enemy named Johnny Cage, and it'll keep on going around to different enemies. Sub-Zero, Scorpion, Sub-Zero, Scorpion, there's Johnny again. So this is working, and it's giving us a random enemy for each one of our levels. I'm going to get rid of all of this here for now, and we're going to talk about why we would even do this. Why would we want to make classes like this? There's a lot of things we could do with classes, and one of the coolest features of classes is inheritance. I'm going to make a new class. I'm going to call it class MK game flow, and we'll be using this to create the game flow in a moment, but right now I want to show you a new keyword called extends. I'm going to extend the MK level class into my MK game flow, making the MK level sort of the parent to the MK game flow. This will give us access to MK level's constructor and anything else in it, meaning I have access to this method as well. So let's work on the constructor first. We will make a constructor in here, and inside of our constructor, we can call the constructor of our parent, what we're extending here, MK level, by running the word super. In order to call MK level's constructor, we're going to need a level name to pass in. So we will take a level name, and inside of super, we'll invoke it and pass in that level name. Now we're going to use the constructor of MK level in order to make a level name. We'll also make a new let's say difficulty, and we could set that equal to medium. Now this class does not have any methods on it at all, but it does have access to methods. So now let's first create an instantiation of this class. Let's make a const called jungle that will equal a new MK game flow. We'll pass in jungle. Let's take a look at what that looks like. Console.log jungle, and run it. Okay, so we were able to access the constructor of the parent here with the super and assign the level name with this level name right up here to the level name passed in. We're also able to make a difficulty on this that would not exist in the MK level, because that's not in the constructor of MK level, it's only in the constructor of MK game flow. So this here comes from MK level, and this comes from MK game flow. Now, the cool thing about inheritance is now we have access to the methods. We could have jungle dot create enemy, and let's make us an enemy in that jungle. Now we have Johnny Cage in the jungle with a medium difficulty. Let's create a ladder. Let's actually make a Mortal Kombat game flow so that we can have different levels and they lead to the next level. And that's what we'll do first. I'll get rid of what we have here, and I'll also get rid of everything inside of here. We're just going to have an empty MK game flow with a constructor that takes nothing. And up here, we will have our MK level. Everything here is going to stay the same, but we'll add this next, meaning who is the next enemy. And to start out, there will be no next enemy, and we'll figure that out as we create the game flow. So we're going to make a actual game flow now. It won't just be one level with one enemy. It will be a level, its enemy, and it will also be a next, meaning where do we go after this level? Now, we're actually making what's called a singly linked list. It will have a start and an end. Sometimes it's called a head and a tail. No matter what, we will start at the start or the head and end at the end or the tail. What happens is we'll have an object. The value might be rooftop in this one, and it'll have a next attached to it. And the value of that might be jungle, and it will also have a next. So saying start.next will get you to this one, which will be jungle. And that was in the next. That was what was being held right here. So we'll have a value of jungle, and it also has a next. And the value there is space, and it has a next. So in order to get to the next item, we will call next on the jungle object here. That will bring us to the value of space here. And it also has a next. And you see how this is working. Calling next on each object brings you to the next item in this singly linked list. We could only move forward because it's singly linked, but we could always go to the next one. And finally, we get a next of null, meaning this is the end of the list or the tail. So let's get started on making this data structure. We'll head back into play code and get started in the MK game flow. So the MK game flow is going to need two things. This .start, and that'll start as nothing. We don't have any levels yet. And this .end, that will also start as null. Let's make our first method on our MK game flow. I'm going to call it make level, and we will work with the MK level class in order to make these levels. So make level will take in level name. We'll have a const called level that will equal a new MK level, and it'll pass in that level name. Then we'll say level.create enemy, and we know what that does. That gives us an enemy for the level. And now we'll have to place that level in the game flow. So a cool thing that happened here is we called a class from within another class. We called MK level from inside the MK gameflow class right here. We made an MK level inside of MK gameflow. And then we said level.createEnemy because we made this const level a new MK level. We had access to create enemy, the method create enemy. But we need to place this somewhere. We need to know if it's at the beginning, it's at the end, or it's somewhere in the middle, somewhere in our next. If we're in the jungle, which is after rooftop, it might not be beginning or end, start or finish, head or tail. It might be in the middle as well. So let's illustrate what we have so far. So we will make a new MK game flow. Let's say const game1 equals new MK game flow. We invoke it and pass in nothing. And then we will console.log game1. We run that. All we have inside of there is a start of null and an end of null. So we have our game1, our start and our end, both null. We've made our game and we need to make our game flow now. So we can make new levels here by calling game1.makeLevel, but how do we place them? We're going to make a new method just for placing them. It'll be called this.sllmaker. And into the SSL maker, we'll pass the level. Let's get started on the SSL maker, SLL maker. So here's our method SLL maker. We know it receives the level, so we could pass in, let's call it level object. And the first thing I want to say is if there's no this.start. So this is a new game where nothing's been added yet. If there's no this.start, the first level object that's added should be the start. So this.start will equal the level object, and this.end will equal the level object. And with this, we're actually able to make our first level and add it to our game. So let's do that. We have our game1 right here. So let's write game1.makeLevel, and we'll pass in the level name of space, and let's run it. We can see now our MK game flow has a start of level space. The next is null still. We have an enemy of sub-0, and we should have a copy of that because there is only one level. So the first level is also the last level. Space, null, sub-0. Perfect. Now that is handled. Let's handle the next level coming in. We'll have our SLL maker, and we want to go to our else. Else will let next level equal this.start. So we know that there is a start value here because we just checked that. The next level is going to hold this.start. Now we'll do a while loop. So while, and I'm just going to pass in true, and we will break within the while loop in order to stop this. So if next level, so that's going to first equal this.start. So if this.start.next is triple equal to null, or we could just say there is no this.start.next like that. Next level dot next will equal the level object. This dot end will also equal the level object because that'll be the new end. Whenever we add in a level, it'll be added to the end. Then when we find it, we'll just break, and we handled our second situation where The next level will be this.start, and we could see on this.start, the next is null. So we have, if there's no next, it comes out to null. Next level.next will be the level object, and this.end will be the new level object we pass in. So if we make another level, we should have a start and an end. Let's make one more level. Right here, we could call game1.makeLevel again, and we'll pass in jungle. And let's run that. Now our start should still be space, and it is. Now our end should be jungle, and it is. The cool thing about our start now, I'll open that up, its next is an MK level, and the level that it is the jungle. So it knows we're now going space, then jungle. But we haven't finished our while loop here. We want to make sure if there's no this.start, we can make our first level. Next, if the next value of this.start right here does not exist, or evaluates to false, is a falsy value, next level.next will be the level object, and we'll have a new end. This.end is the level object. But what if the next level.next has a value? We want to iterate to that next value, and we can do that right down here. Just with a quick else statement, next level will equal next level dot next, meaning we will go to the next one, and then we'll run this while statement again until we find a next level whose next is falsy due to this exclamation point right here. So we should be able to make as many levels as we want now. Let's make one or two more. We have the jungle. Let's do Wild West, and about mountain. That'll be one of the levels. Okay, now we can run this, and we should actually have an MK game flow going with 4 levels in it. Let me move this up a whole bunch so we could really look through it, and let's run it. Okay, we have an MK game flow. It starts in space as it should. The next level is the jungle, as it should be as well. The next level is the Wild West. And finally, we get to the mountain. And we should have an end here that has the mountain and a next of null. A very common JavaScript interview question is, how do you reverse a singly linked list? Let's tackle that through object-oriented programming. We have our MK game flow, and we see we have our SLL maker as a method. We also have our make level as a method. We're going to have another method in here called reverse. So reverse, and that will be a method. We'll take in nothing. We're going to now call this a node. Each one of the pieces of, let me show you, of the list. This will be called a node, this will be called a node, this will be called a node, and so on. So we're going to let node equal this dot start. We can let previous, let's call it prev, equal null, and let save, and that doesn't need a value. So this dot start is the head of the list, the beginning of your SLL, the start, our start here. Now what we want to do is reverse this list, meaning we want the arrows to point the opposite way. We want rooftop to point to nothing. We want jungle to point to rooftop. We want space to point to jungle, and we want volcano to point to space. We're going to do that with the variables we just made and a while loop. So while node, and I'll do this all in pseudocode so we could go through it slowly. First, I'm going to save the next value. Okay, and then after that, let's change next to prev. So that's the value being held right here. And just to make this more clear, we're going to say node.next. We're going to be using the node's next value. I'll write this here too. Node.next is going to equal the previous. So we're going to save what is the current node next into save, and then we're going to change the node next to equal previous. And since that's null at the beginning, that works out perfect for us. It will change the next value of the first one, rooftop, to null. But we're going to need to work even a little bit more by changing now the previous, the prev right there, change prev to current, which would mean changing the previous to the current node that you're on. So maybe write current node. The first time through, instead of it previous equaling null, previous is now going to equal rooftop and iterate over to jungle. And jungle's next should be rooftop. And since now rooftop is being held in that prev value, that previous value, the next should point to rooftop. We'll also need to go to the old next node. So go to saved next node. That's what we saved right at the beginning. We saved that value of the next node so that we could iterate to it. Finally, outside of this loop, we're going to need to change the head and the tail. So what is the start and the end? We need to change those two, and we just need to swap them. There's a really cool way to do that, very simple way to do that. We make an array, this.start, comma, this.end, and we set it equal to its opposite. This.end equals this.start, and we flipped those two. Let's get started on our while code here so we can finish up this reverse method. The first thing I'll do is save the node.next value. So save will equal node.next. Change node.next to previous. Okay, so node.next will equal previous. Then we will change previous to the current node. Oh, I wrote fully previous. We named it prev. Okay, so we'll change prev equal to node. And then we're going to go to the next node that we saved right here. Okay, so now node will be reassigned to save, which is what we did right here to the original node.next. Now, if you have your head all wrapped around this already, that's fantastic, but otherwise you might want to look at the diagram a bit, think about reversing the arrow and what that means. Meaning the first time I reverse the arrow, this one actually points to null. So that's what we're doing first. The next value is null, and that's what we want because the end needs to have space as its next value. Space needs to have jungle as its next value. Jungle needs to have rooftop as its next value, and rooftop needs to be the end of the list, meaning its next will be null. Well, let's try this out. We just did all that work. Let's make sure it's working. We have our game1 here. I want to game1.reverse. And I'll pull this up so we could really see what happens when we do our reverse. There seems to be an issue here. Let me see what the issue is. Get you out of the way. Oh, this was a mistake. This should not be an equal sign. That's got to be it. I'll run it again. Okay. Now we have our start is mountain. And let me see if I could bring this into view so we know that it flipped around. There we go. The start is mountain. That used to be the last one. The second one is the Wild West, so that works perfect. Now we go to the jungle, that's right there, and we have space finally right there, and its next is null, so we did turn everything around with our reverse function. So we just did a lot of object-oriented programming, and actually there's one more thing to check. You should be space, perfect. And we did a lot of object-oriented programming, and we created really cool MK level and MK gameflow classes and let them work with each other. Now, what we learned at the end, when we actually did the reverse here, this is something that you should look at several times, figure it out, because it might come up in an interview. Reversing a singly linked list is a popular JavaScript interview question, and we not only reversed one, we created one, and we did it all in object-oriented programming. So if you get questions about object-oriented programming, you could come back to this knowledge in order to answer some of those. I like working with objects like this. It's a pretty cool way of doing things, and if you are interested in making video games, stuff like that, you'll be working mostly with object-oriented programming, so that's why I picked this example. Thanks for being with me on this one, and keep coding.